Delaware Tech, Chemistry 100, Chemistry 110, Measurement and Estimation in the Lab. You're going to be exposed to a lot of equipment when working in the lab, whether you're doing it physically in the lab or doing virtual labs. We divide equipment into two major categories: the digital equipment, which is equipment that has digital display, so it gives you the number value of whatever it is you're measuring directly. The machine does the work for you. We also have non-digital equipment known as analog devices or analog instruments. And these are ones in theory where you could read any value between two different marks that are marked on the device itself to measure a particular value. So if you had a line shown here and you brought in a ruler, and we're not going to worry about units right now, you can look at this and you can see that the length of this red rectangle here, the red line, is not exactly on any one of the particular tick marks, what we call tick marks or hatch marks or hash marks, on the ruler. It's somewhere in between. It could be right on the mark, but it could be right in between very frequently. This is an analog device. It could be any value. So these would include rulers, thermometers, as long as they're not digital thermometers, and graduated cylinders. Graduated cylinders are cylinders, as the name suggests, that hold liquid in the lab and are marked with very fine, detailed tick marks on them to tell you the volume at various points along the cylinder. And you can read these tick marks with your eyes and make your own value judgment, as opposed to an electronic device like an electronic balance, which will tell you the answer. It will give you your mass to the nearest gram or the nearest hundredth of a gram or a thousandth of a gram, depending on the precision of that particular digital instrument. So with any analog device that you can see with your own eyes can subdivide between any two tick marks into 10 individual pieces. In other words, you can divide it up tenfold. So if you look here at the ruler shown above, you see that the red line is between 4.3 tick marks and 4.4 on the tick marks. And you, with your own eyes, can decide another decimal place, one more significant digit to the measurement, also referred to as significant figures, or sig figs for short. You can even see it abbreviated as SF occasionally. So anytime you have an analog device, you can always add one more significant digit, one more decimal place beyond what the instrument reads in terms of its smallest tick mark. For example, not in this particular case, but let's say you had a length that was between 7.5 centimeters and 7.6 centimeters as marked by the tick marks on your ruler. But you notice that the length is a little bit closer than to the 7.5 than it is the 7.6. You might estimate that your final answer was 7.53 centimeters. So your estimated digit is now the last significant figure or significant digit in your measurement. If we look here at the top, at this example, you notice it's between 4.3 and 4.4. I would say that's a little more than halfway. I would give it 4.37, whatever the unit is, but you might say it's 3.46 or 4.36 or 4.38, depending on what your eye and your brain tells you it is. So there's always a range of what is acceptable, but you do have to be careful you don't go outside of what is really an acceptable range by a person with good eyesight. Note that the digital device, the last decimal place in the digital device, is actually estimated by the digital device. So that device is making an estimate for you. So let's look at some examples. Here we have another ruler with some rectangle we're measuring the length of, and we have a thermometer in degrees centigrade. And if we look at the ruler here, you notice it's in centimeters, and we've lined up our edge with exactly the 0 centimeter mark. Some rulers are kind of damaged at one end of the ruler, so you may want to start at the 1 centimeter mark or the 10 centimeter mark. Just remember to subtract out that additional centimeter or 10 centimeters later. You don't want to include that in your length. That's so that you know you have a good straight edge to use for your measurement. And you'll notice in this case, we are between 4.2 centimeters and 4.3 centimeters, a little closer to the 4.2. So I'll make an estimate here of 4.24, but you may have made an estimate of 4.23 centimeters or 4.25 centimeters. Either of those would be relatively acceptable, but do your best. You can always blow these slides up and look at it in detail. You may not have that opportunity in a real-life situation in the lab, however. Let's look at the centigrade thermometer on the right. You see that the measurement is above the 34-degree mark, but below the 35-degree mark, just barely below 35. So you might estimate this to be 34.8 degrees centigrade, maybe a little lower, 34.7, maybe a little higher, 34.9. It's your estimate of the last significant digit. And now that said, be aware, whatever the instrument has tick marks to, you can add one more decimal place to. So if it only is every 1 milliliter for the smallest tick mark, well, then you can measure to the 10th of a milliliter. If it's every 10th of a centimeter in your ruler, you can measure to the nearest 100th of a centimeter as shown here. You can have something where it's only good to the nearest 10 whatever unit you're looking at. Well, you can only divide that into 10 more, so you'll end up being to the nearest 1. So you have to be careful what the instrument has in terms of its tick marks, and then you can add one more decimal place. And with that, we'll look at another situation here with volumes. And volumes are slightly trickier. Volumes are typically measured in the lab with a graduated cylinder. This is a cylinder marked in gradations, steps, that tell you the volume to a reasonable degree of precision. And whenever you have a solution in a cylinder, you'll notice the top surface forms a curve. Typically, if this is a water-based solution, an aqueous solution, this curve will be pointing up. In other words, the lowest point of the curve will be in the center of the curve. And we have a name for this curve. It's called a meniscus. And the meniscus can be curved like this for water. And you will always, no matter what shape the meniscus is, read the lowest part of the meniscus, because all laboratory graduated cylinders and any volumetric device in the lab has been calibrated to match the bottom of the meniscus. Wherever the bottom is, whether it's in the center, and the sides, or somewhere else, the bottom is where you're always going to look at. And that means that you need to drop to eye level, put your eye right next to it. Of course, you're going to be wearing goggles, and read as best you can the level of the bottom of the meniscus. So in this case, I'm estimating that this volume is between 37 and 38 milliliters, and a little bit closer to 38, so I'm saying 37.6 milliliters. And note that for some liquids, like mercury is a metallic element, it's a metal, but it happens to be a liquid at room temperature, the only metal that is a liquid at room temperature, and only one of 2 elements on the whole periodic table that is a liquid at room temperature, the other one being bromine, a non-metal. And mercury does something funny. Its meniscus is inverted. In other words, the edges point down instead of pointing up along the sides of the graduated cylinder. But you still have to read from the lowest point, the bottom of the meniscus. And the bottom of the meniscus, in the case of mercury, would be the edges where it's lowest. So just be aware of that whenever you're measuring. And with that, we'll stop here.